Hey guys, welcome back to the rest of the sex linkage video. So we just finished talking about how color blindness, I'll go back a slide here, is linked for humans on the X chromosome. So color blindness, like I said before, is linked as in X big C means you're normal, X little c means you're blind. So in the relation of sex linkage, it is very hard for females to have diseases that are sex linked because they need both recessive X's, one from mom and one from dad. So you're going to see how that trends through as we talk about pedigrees later on. So another example of sex linkage in humans is hemophilia. And I don't know if you know what hemophilia is, but it is an issue with blood clotting, and it tends to lead to people bleeding out internally. It is the lack of the blood clotting factor, and there's actually severities amounted to it. So like it could be severity 4 or something like that. Okay. These are found on the X chromosomes. Now, the interesting thing about hemophilia is because it is a recessive trait, when you get a lot of inbreeding causes a lot of these recessive traits to rear their ugly head. So if you hear the story of like the Romanovs in social studies, who were the last czar of Russia, and his family before when Rasputin kind of got them killed, his son actually suffered from hemophilia. And the reason his son suffered from hemophilia is a ton of interbreeding that occurred, or inbreeding, I should say, occurred in the lines because they wanted to keep the bloodline royal, right? Again, something that is sex linked affects boys more than girls because they only need one affected X to be sick. So the phenotypes for this are big H, or big H, little h is going to be normal in females, and two little h's are going to show up as hemophilia. Males, all they need is one big H to be normal or one little h to be to have hemophilia. Again, there is no in between. So it is easier for boys to have the disease than it is for girls. So make sure you put this all down into your notes because we had to write out the phenotypes. So there's an example. So these are famous people. Hopefully you recognize some of them that have had hemophilia. So this is the family I was talking about. Tsar Nicholas and his son right here had hemophilia. Abraham Lincoln suffered from hemophilia. Mother Teresa suffered from hemophilia. For the life of me, cannot think of who she is, but she is funny, and she did. And then these are just examples of other royals that have suffered from hemophilia. This is Queen Elizabeth. So here we go. Let's continue on in our journey, but I just had to throw a little joke in there, in case you were wondering. So hemophilia, this is a slide from Mrs. Edmondson's beautiful group of friends, and she tells a story about her friend who suffers from hemophilia. To keep this video short, will tell this in class. Normally I would tell you about it in this slide, but I'm not going to today. So that is sex linkage. Now we're going to go into the world of calculating probability in genetics. Okay, so taking sex linkage and kind of making sure you have that written down. We're now going to talk about how sex linkage is highly linked when we talk about probability in genetics. So in genetics, we are very much about determining the probability or the chances of events occurring. So in heredity, you have to remember previous events have no effect on the chances you have at the current moment. So if you had a baby girl the first time, you still have a 50-50 chance the second time to have another girl or have a boy. Okay. It's not like, oh, I had a girl the first time, so it says that I should have a higher chance of having a boy this time. That's not how it works. Okay. So just because you have 3 daughters does not mean that you will have a 100% chance of having a 4th daughter. It again goes back to 50-50. So when we solve for probability, this is the events of probability, the number of chances over the possible combinations. That needs to be in your notes. So we call this the product rule. So what happens is sometimes when we are trying to figure out the options for probability, we have to look at events occurring simultaneously. So the product rule is saying that 2 events are occurring at the same time. What is the event probability of event 1 and event 2 happening? And we're going to multiply them together. Okay, so make sure this is in your notes. We are going to do practice, and I'm going to explain little tips and tricks to help you figure out the difference between just doing a regular probability question and then one that is a product rule. Okay, so the last thing we are going to talk about here are other gender-related traits, and we are saying that they are X-linked, but they are sex-limited or sex-influenced, meaning sex-limited means it's only in one gender. Okay. Sex influence means it shows up in shows up in one gender more than the other. Okay. So milk and cows. for example, is sex limited. Okay. Bulls carry the gene, but they don't actually produce milk because they have the Y chromosome. Okay. Sex influenced is different. Males and females can suffer from male pattern, well, they call it male pattern baldness, but it's a pattern baldness. Okay. And it's influenced by testosterone. It's a dominant gene in males, but recessive in females. Since it's recessive in females, it doesn't occur as much. So it's more common in males. Therefore, it's sex influence. Two X's influence it compared to an X and a Y. So that's the difference between sex limited, meaning it is or isn't in one gender, where sex influences, it can be in both, but one is expressed more. So Y-linked traits, Y-linked traits then state that it only happens on the Y chromosome. So again, if we come across an example like this, it is only going to be passed from father to son. Male infertility is an example of this. Why? Because we need testosterone to produce sperm. If we don't have testosterone, we can't produce sperm. Testosterone comes from the Y chromosome. Okay, so that's just an example of how it's passed from male to male. Okay. Bar bodies, we're going to watch a video on this, okay? Bar bodies happen because women have two X's, okay? So we have double the number of chromosomes that men do. Hence, we get this idea of twice the gene dosage. Sometimes that's good and sometimes that's not. That's bad, okay? So bar bodies are actually found in the X chromosomes, and they turn off what are called bar bodies, or these black dot shapes, okay? They have an inactivated group of chromosomes, and it just essentially means that it turns on and off genes in certain cells. I'm going to show you a video that kind of explains this better, so just write these notes down and then we'll kind of add on to these notes with the video I will show. So in this sense of bar bodies, humans have bar bodies, but the best way to look at bar bodies is through examples of calico cats, okay? Calico cats are normally, and I'm going to be very careful saying this because it turns out that there are other examples, but are normally female cats, okay? Hair color is determined by the X chromosome on the female cat. There's two types, O and B, orange and black. In this case, guys, yes, they are two different alleles, and that is because, or letters for alleles, is because they are both expressed in a co-dominant relationship. We haven't learned that yet. We will. Don't stress if you don't understand why I have those letters, okay? So for males, if you have an O, you will be orange. If you have a B, you'll be black. In females, it's the same. O, and B, orange and black. Here's where we get a unique sense. Females with the genotype of O and B, so heterozygous females, will end up actually having different patches of skin that are showing different colors due to the activation or inactivation of the X chromosome bar bodies. So in the cells that are found on this part of the cat's face, the black chromosome, or XB, is turned off, whereas the XO is turned on. So you see orange on this half of the body, but you see black on this half because it's the opposite. So when XO is inactive, you will see black, and when XB is inactive, you will see orange. We call these calico cats. So it turns out, for a long time, I was like, oh yeah, calico cats can only be females. They can only be females. They can only be females because they need an X and an O and an X and a B. But it actually turns out that you can have a male calico cat. I'm not going to tell you in this video how. I want you to think how this is even possible based on the fact that I told you calico cats only happen when you have this genetic set. So think about it. We're going to talk about it in class. All right. Make sure you pause and stop both videos to ensure that all your notes are filled out. I am looking at them tomorrow, and we're going to start practicing our questions together tomorrow. All right. Have a great evening.